we are now ready to compute our index. We are working on script 6a, where we can calculate the VCI. The formula for VCI says you need to take the current image, compare it against the image of the minimum NDVI and maximum NDVI. And then you can apply this formula, the current NDVI minus minimum NDVI divided by max minus min at each pixel. And since we're doing monthly VCI, we need to now have monthly images for each month. And then we can say, this is the May 2023 image. Tell me what was the minimum May NDVI, what was the minimum May maximum and May NDVI, and then we can compute the VCI in the current year. Okay, so we now say for each current year image, we have the monthly images, we compare it against the minimum and maximum NDVI at that pixel over the last 10 years, and we can compute our VCI. The way the script is set up is you define the year and the month you want your VCI to be. VCI always is from the current year to 10 years back or more years back. So for example, if I wanted NDVI for 2023, I would say 2010 to 2023. And then I would say I want 2023 December, right? So you always include the year of the current year in the as an end year. So for now, we just say, assume we are in 2020. We are computing the min max from 2010 to 2020. And we want to know in May 2020, what was the VCI? So we say, this is the current month, this is the current year. We take our monthly collection, get the current month's NDVI. We already have the min and max NDVI for the month of May, and we load all the images on the map. So if I zoom into some area, let me zoom into some agriculture area. And let's just inspect some pixel value. So this is what we see here, that the current May NDVI is 0.18. Historically, the minimum has been 0.16 and the maximum has been 0.26. So what's the VCI? This looks like it's very close to the minimum NDVI. So it's actually not looking good. It's actually at the 10-year minimum period. If you look at some other pixel, we say the minimum was 0.2, maximum 0.36, current is 0.35. So we are doing pretty good compared to the historic average. That's what VCI is. Current month's NDVI compared with the min and max. Let's quantify it using the VCI formula. This is the VCI formula. To compute the VCI, we need to have the NDVI image, min image, max image, and compute that. Easiest if you want applying this formula, just put everything into a single image. So we can use the eImageCat function, which will take a list of images. We'll just put them together. So we'll say, I'll put the current month NDVI as a first band, the min NDVI is a second band, and max NDVI is a third band. So we create a 3-band image out of this. We can also just assign a proper band name so we know what those bands are when we look at the image. So now we've created a kind of a stacked image from the 3 different bands that we created. So this is a 3-band image. The current month's NDVI, historic min, historic max. Let's implement the VCI formula. We can use the image.expression function. Remember, this expression function is same as what we used for computing more complex indices. We need to give a formula and then define what each formula parameter represents. So the first parameter is the formula, and we can write it as like a human readable expression. So we said, this is my expression. Now, to define, what do I mean by NDVI? What is NDVI in this context? And we say, this is from your image, you select the NDVI band and replace the value of the NDVI band and is wherever you see NDVI. Same with min, you take the image, select the min value, and same with max. And the output will be the VCI value. And again, a reminder, this values can be anything. If I say X here, I just need to say X is this. Whatever parameter I've used in the formula, I just replace it with the value and say, wherever you see this variable, replace it with the value of this band. Let's visualize the VCI. We will, VCI is 100 times this, so it'll be in percentage. So the min max will be like 0 to 100. So we'll say min is 0, max is 100, and we can give some palette. I'll give a kind of a colorful palette here. And we'll just keep that as a palette. And it's useful to have your other layers on the map. This is very important when you're working on this complex project. You would like to validate your result. So you can just inspect the pixel. You have the input values. You can do a hand computation and figure out if the formula was correct. So now we have this map. Red is bad, green is good. So you can see all the regions where we have low VCI and high VCI. Let's take a look at some of the regions. So you can see all the red areas are experiencing bad VCI. Let's inspect the pixel value. The VCI is 40. And you can now look at it and say, this was a historic min, this was a historic max. You are very close to historic min. So you are 40. There are other regions which have very good VCI. Select this and you can see now we are close to the maximum. It's a 46% VCI. And that's how we computed VCI. 0 to 100%, we get an indicator how healthy the vegetation is compared to the historic average. This is just the VCI image for the May of 2020. If you wanted VCI for every month, put this computation in a function, map it over a list of months, and look at VCI for that each month. The question is why percentage? Yeah, VCI is usually expressed in terms of percentage, and there is a classification that is used to say if VCI is below a certain percentage, then it's a drought. So it's more interpretable. You could keep it between 0 and 1 if you don't multiply it by 100 and use that. But typically, the VCI is expressed in terms of percentage. That's why we use that multiplied by 100. And the question is, can we do this using Black or Sentinel-2? You can. Sentinel-2, you're restricted to imagery from 2017 in most parts of the world. So you don't have enough data to have a historic minimum maximum. Landsat, yes, you can do that. So if you take a Landsat collection and compute this, you can implement the same thing, and you need to apply the Landsat cloud mask, aggregate images for a month and so on. Again, Landsat, in many parts of the world, you have images every 16 days. And if that is cloudy, that month is missing the observation. So you need to be careful about, certain months you may not be able to monitor, but the months that you have enough cloud-free observations, you will be able to use that. And the question is, is there a code for this on Landsat? You can just essentially use the same code template and just replace a Landsat collection and Landsat cloud mask. All right, let's do the exercise before we take the break.